Okay, gang, I made a typo, so let me just start this again. You're going to use a quotient rule here. So it's the denominator times the derivative of the numerator. This is just negative 2x. Okay, derivative of this is negative 2x. So the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, that's the derivative of the fraction. And I was just simplifying it, and I noticed I had a typo, so I went back. So now I'm here. I'm foiling this out. Now I'm foiling out the derivative. I wrote that one. Okay, so now I'm over here. So this is negative 2x to the third. This times this is a 3. This times this is a 2x. All right, now over here you have to distribute both the negative and the 2x. So if you want, you could just think of it as negative 2x that you're distributing through. So negative 8x, 6x squared, 2x to the third. Okay, so now I'm going to combine like terms. So cube terms are here and here. Okay, negative 2 and a positive 2, that goes. All right, quadratic terms are here and here. Negative 3 plus 6. Negative 3 plus 6, okay, that's 3x squared. Linear terms are here and here. So it's negative 6x. And the constant is here. All right, so that's where we are so far. Now the thing with these type of problems is you want to simplify them as far as you can. For one reason or the other or both. So one reason can be you just want to have it completely simplified. It's a fraction. And the other reason being you want it as factored and simplified as much as possible because you're going to be solving soon. Like you're going to have applications, word problems. Or you're just trying to solve something on a graph, so you always solve these in a factored form. Okay, so you always want to see, can I factor this further? Can I reduce this further? You want to just go as far as you can with these problems. So now I'm going to look at it again and see if I can do anything else. So I'm noticing that there's a common factor of 3 in the numerator, so I'm going to take a look at that. Okay, that had a common factor of 3. Now I'm looking at it again. This is factorable. Okay, interesting. These look very similar, but they're not quite the same. So like, for instance, if I just look at this right here, not the squared yet, this factors into x plus 1, x minus 1, just this part here. But then this thing is being squared, which means that these are being squared, okay? So what I wrote here is just a factorization of this, but then this was being squared. All right, which means that I have this scenario. It means that each of these are squared. And then you might know where I'm going with this, right? You're going to say, oh, that reduces with that, and you'd be absolutely correct. So the final answer here, that's interesting, the way this one is working out. Sort of that satisfied feeling when you do all that work and you get that sort of real simplified answer like that. All right, gang, that's it. That is it. That is the final answer. Hope you enjoyed it. Bye-bye.